In our past few lessons, we've spoken a fair amount about the intercepts, finding the zeros and the roots. Now we need to talk about finding the vertex. When we have a question here that's in standard form though, finding the vertex can't be done at a glance. We're going to have to do some calculations in order to find it. There's 3 different ways of doing that, and that's what we're going to look at today. We're going to look at how to find the vertex by factoring, by partial factoring, and by completing the square. So the first way of doing it is let's look at factoring. So when I look at the equation, the first thing that I'm going to do is I'm going to common factor, because I never want to get into decomposition unless I have to. So when I common factor, I'm left with negative 5 t squared minus 8t minus 20. I always carry through that negative 5. I don't lose that along the way. My magic numbers are negative 10 and positive 2. So I know that my x-intercepts happen at positive 10 and negative 2. So I'm just going to do a quick sketch here. It's always helpful for you to do a sketch whenever you're doing any of your quadratic work. So my first intercept happens at negative 2. The other one happens at positive 10. I know that my graph's going to open down because my a is negative. So I'm just going to go through my graph, show my parabola there. And you can tell it's pretty good. My vertex is about halfway between those 2 intercepts. It's symmetrical, so I know if I was to actually graph this, not just a sketch, that my vertex would be right in between those 2 points. So I can find the x value of the vertex by finding my axes of symmetry. So my axes of symmetry, which is exactly midway, so you just average them. So x plus negative 2 divided by 2 gives me the middle number. So 8 divided by 2 equals 4. And that's my axes of symmetry, which you can tell your axes of symmetry is also the x value of your vertex there. So if I substitute it back into my original equation and solve, I can find out what the y value of the vertex is. So I have negative 5, 4 squared, plus 40 times 4 plus 100. Plus 160 plus 100. So this here gives me negative 80 plus 260, which equals positive 180. So therefore, my vertex occurs at positive 4 and 180 on this graph. So I'm going to continue on using the exact same example, showing you different methods on how to get to the vertex. And of course, all methods should get you to the exact same vertex. So the example we did before was negative 5t squared plus 40t plus 100. So we can partial factor this, which means a really fast, easy common factor of our first 2 terms, because everything with parabolas is symmetrical. So if I don't need the zeros at all, if I don't need to find the x-intercepts, I can partial factor this equation, which means I can common factor the first 2 terms. This leaves me with t minus 8 plus 100. I don't even need to look at that. So what I have here is my zeros, 2 symmetrical points of t on this graph, first one being 0 and the second one being positive 8. So on this graph that we saw earlier that was at negative 2 and 10 and opened down, had a vertex at 4, at 0 right there and 8 right there, we have 2 symmetrical points. So as long as I have those 2 symmetrical points, I can still find my axes of symmetry by averaging them and substituting back in to find the y value of the vertex. So now my t axes of symmetry is 8 plus 0 divided by 2, and you can see here it's already getting me the same axes of symmetry, which is 4, showing there on the graph the time is 4, and then you substitute back into your original equation and solve for the height. So when it's 4, we have negative 5, 4 squared, plus 40 times 4, plus 100. So I don't need to go through those exact calculations again for you to show you that it is 180. So our vertex then, just to answer the question, if you partial factor, happens at 4 and 180. And you can see that's such a fast method of finding the vertex, as long as you don't need the actual x-intercepts. You have to keep in mind with partial factoring, you're just getting two symmetrical points on the parabola. In our last method for completing the square, this is going to take the whole standard form and convert it to vertex form. So I'm just going to rewrite the equation so we can see it. Negative 5t squared plus 40t plus 100. So our very first thing that we do is we common factor out the coefficient only, which means not the variables, from the first two terms. So that leaves me with t squared minus 8t plus 100. So it becomes a little bit confusing here when you get through the partial factoring, so it's good to review this video to remind yourself what the differences are. So I'm not factoring out a variable here. Now I leave my coefficient factored out there, and I do a little bit of side work to find out a number that I can add and subtract in. So I take my 8, I divide it by 2, and I square it. So I have 4 squared, which equals 16. So that's really important. So I'm just going to show you up here too. It's b squared, b divided by 2 squared, to find out a number that we can add and subtract in. So here I'm going to add in 16 and subtract 16. And I'll show in a little bit, this will make some sense. What we're doing is we're making a perfect square trinomial, an easy way of factoring we learned earlier in this course. The reason I can add and subtract this 16 here, it doesn't change the value of the equation at all. You can see all I've done is add in 0. So I can add in 0 anytime if I want, if it helps me, as long as it doesn't change the equation or the value. So now that I have that, t squared minus 8t plus 16, I want to remove this negative 16 from the brackets, because I see here, these three terms make a perfect square trinomial if I only remove this negative 16. And I can't just do it because it makes my life easier. It has to be mathematically sound. So don't forget, I have to do distributive property to it. So I'm going to have to take this negative 5 and multiply it by negative 16, and then I can take it out of the brackets. So negative 16 times negative 5 is positive 180. So I'm going to clean this up a little bit before I do my factoring. Eventually, when you get good at it, you can probably just jump right to your factoring there. Some of you might already be doing it. Plus 180. So now my perfect square trinomial says if I can factor the first term, square root the first term, square root the second term, multiply it by 2. If it equals the middle term, it works. So I'll just show you quick rough work. What I'm saying is the square root of 1 is 1. The square root of 16 is 4. If I multiply it all by 2 and it gives me the middle term, then it's a perfect square trinomial. So I square root my first term, I carry my sign through, square root the last term, put the square there plus 180, boom, I'm in vertex form. So I can see here that my vertex is 4 and 180, which matches the other two ways of doing it. If you want to see one other example of completing the square, there's a second video attached to this one in the lesson, also on YouTube. That's it for today. We'll practice all three methods in class tomorrow.